So chapter 3 is all about graphing, functions, relationships, input, output. So we're going to take a look today for section 3.0, graphing relationships. And graphs represent relationships within information. And most of the time we talk about information in terms of data. And that data can either be descriptive or it can be numerical. Obviously, descriptive has more to do with words. Numerical, we're going to be taking a look at in math class. So here's your big ideas for this video. Numerical data can be discrete or continuous. We're going to be looking at both of these ideas in this video. So first of all, discrete. Discrete data is either counted or listed. And a good picture of a discrete model is rolling a die. So here's a die, and this is my die, Mrs. Hendry. And obviously a die has 6 sides, not 5 1/2, not 4 3/4. It has exactly 6 sides. And those 6 sides all have a number on them. So if we are talking about discrete data, normally discrete data is given in a roster notation. So if we're rolling a die, we're either going to get a 1, a 2, 3, 4, 5, or 6. Not an interval, but a particular set of numbers that can be counted or listed. Another example would be the number of dogs at a rescue shelter. And if we were going to actually go to the rescue shelter and count the dogs, let's say that there are dogs, let's see, the dog named Joe, the dog named Shep, the dog named Mick, the dog named Buster, and so forth. ... all the way through, we'll say, the dog named Zach. Now, these are all names of dogs, and the dogs can be counted or listed. We would not say that there are 3.75 dogs at the rescue shelter because we only count whole dogs. That's why we're able to count them or list them. List them by name or count them by number. So those are discrete data. Next, we've got continuous data. Continuous data can be measured. And here are some examples. A person's height is a continuous data measurement. We might say that someone, and especially if a baby is born, we might say that a baby is 19 3/4 inches. That's a measurement. The times for the runners in a race is a continuous piece of data. So we could say that we have 4 runners in the race, and maybe they're all running the mile, and the first one runs the mile in 4.72 minutes. He's the winner. The second one is 4.89 minutes, and then third place is 5.02 minutes. So continuous data is measured. The times for runners in a race. Continuous measurements. Next, also the amount of gas in a car's tank. The tank is not either empty or full, but the tank, if you think about it, normally when you look on the dashboard, you see something that kind of looks like this, where here is a quarter, here is a half, here's 3/4, and here's full. Here's empty. That little meter could be anywhere on that particular gauge. Maybe the meter is showing right here. That's in between a quarter and half. But if it can be measured, we say that it is continuous data. So discrete versus continuous. We see that in the graphs, the charts and graphs that we use in algebra. So here's an example. Sketch a graph for the situation. Tell whether the graph is continuous or discrete. So Jamie is taking an 8-week keyboarding class. So right away, I just want to let you know that 8 weeks is right down here on the x-axis, and pretty much any time that we are discussing the whole idea of time, it is going to go on the x-axis because time is almost always the independent variable. The independent variable is time. That is something that we cannot change. So Jamie's taking an 8-week keyboarding class. At the end of each week, she takes a test. Not every day, not every minute, once per week. She takes a test to find the number of whole words that she can type per minute, per whole minute. She improves each week. So what we see here is that at the end of week 1, she can type 20 words per minute. Let's zoom in on this so you can see it a little better. At the end of week 2, it appears to be about 23 words per minute. After 3 weeks, about 30 words per minute. But these are definite, discrete values. This is not a continuous flow of words throughout the week. Once again, she's taking the test at the end of each week. This graph is discrete. Next, the air temperature increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. Choose the graph that best represents the situation. So right away, I see the word temperature. Temperature is a measurement of heat. So right away, we're measuring something. Right away, I'm thinking this should be continuous. Next, I see some other words that give evidence to the fact that this is a continuous graph. The temperature increased steadily for several hours. So once again, it's letting us know that our independent variable is time. Independent variable is time. And what is dependent upon the time? The temperature is the dependent variable here. So the air temperature increased steadily for several hours and then remained constant. So let's start taking a look at these graphs. So if time starts 0 here at the origin, and it says that our temperature increased steadily, does this appear to be a steady increase? No. When we see a flat line here, that is a constant slope. So the temperature is doing nothing in this graph. It is definitely not A. And then what do we have? The temperature increased steadily. Again, is that a steady increase in temperature? No. So it cannot be B. It must be C. Let's finish it off. The temperature increased steadily for the first several hours and then it remained constant. So then the temperature leveled off. Then what happened? At the end of the day, the temperature increased slightly. So next, we have a slight increase before dropping sharply. So a slight increase, and then at the end of the day, the temperature fell. Fell how? Sharply. Dropped sharply. So this problem is filled with language that is representing continuous data, where non-stopping, not stopping, not for a minute, not for a second, time was continuing to pass. This is a great example of a continuous graph. So one last quick review. Continuous data is measured. Discrete data is counted or listed.